not as in cobalt chrome partial dentures. So it's a cobalt chrome, cost-effective cobalt chrome alloy. We also have it available in titanium with a veneering ceramic that bonds onto the titanium. It's for some full contoured crowns, as in Emax and Telio CAD. This is a Telio CAD temporary acrylic material, and we'll get into that a little bit more. It's for abutments, for our implant systems and some other competitor implant systems, as in individually customised abutments where we need angulation corrections, or for whatever reason we need a customised abutment. That's what the NobelProcera scanner is designed to do. And it's for bars, overdenture bars, both fixed bar with a removable prosthesis and fixed bars, fixed hybrid bars. As you can see, there's a variety of materials. Some are only single units, such as the Emax is only available in single units. Telio CAD, cobalt chrome, alumina, titanium, zirconia. For bridges, zirconia coloured titanium. For director fixture, customised abutments. In that director fixture, it means that the layering, the veneering material, ceramic, composite, whatever it is veneered directly to the abutment, so it's a single tooth director fixture. Customised abutments for cement-on crowns or transverse screw-retained crowns, if that's what you prefer. And bridges for direct ceramic laying bridges. And overdenture bars, virtual designed overdenture bars. These bridges are what we call a PIB, which people commonly know them as a PIB. The PIBs are available in zirconia, coloured zirconia and titanium, whereas this next bar down is a virtual designed overdenture bar. So it's designed on the computer, which is distinct from a copy milled PIB bar. In terms of the process, the purpose of the scanner is to be more efficient. The traditional technique, if you like, in the lab, you wax up, sprue, you invest, you burn out, you cast, you devest that casting, you finish the metal and prepare it for ceramic bonding, then you apply your opaque and your porcelain and you build it up. For a pressable ceramic material, it's a very similar sort of process. You wax up the framework, you sprue it, invest it, burn out, press, devest it, and then you veneer your ceramic or stain and glaze, depending on the system that you're actually using. The idea of the NobelProcera scanner is that you scan and design, and the laboratory focuses all their energies on the layering ceramic, the veneering, rather than on the fabrication of the framework. And once again, so for the dentist, the traditional process, preparation, takes an impression, pours up the model, the laboratory pours up the model, waxes it, invests it, casts it, etc., etc. With the scanner, the dentist prepares the tooth, takes the impression, a model is still fabricated, it's scanned, then it's sent off for production, comes back, the framework comes back, and then the ceramic is layered on top. So what is the scanner, for those that want to know? It's a conoscopic holographic laser scanner, or it's a non-contact laser scanner. Can you see my mouse? Oh yeah, that's good. So the laser is very controlled in that there's a series of mirrors here. The laser comes down there, hits, the computer decides how many mirrors need to be involved based on what you've told it you're trying to scan. So it can incorporate 1 mirror, 2 mirrors, 3 mirrors, 4 mirrors. The computer decides how many mirrors it needs to incorporate to capture the information that it needs to. And the information, the laser is then sent down to the model, back up to the receptors, and then transferred across to the computer. It is an open-air design. People often ask me, how long does it take to scan? My answer is it depends what you're trying to scan. If it's just a basic single unit, we can actually scan 12 single units at a time. 12 single units take a bit longer than maybe doing 2 single units if you do them in the actual models. If you're scanning adjacent teeth, bite registrations, soft tissue, things like that, it scans them very quickly. Preparations, implants, it takes longer to scan those. But it's still only a couple of minutes to scan something. Full arch dentures, they take a bit longer. It's not just the scanner that our customers invest in. It's the new production technologies. It's constantly ongoing changes to the manufacturing, whether it's a laser deposition machine for precious alloys or for titanium, whether it's some of the new resin printers or the new printers that are printing out titanium and various other materials. We invest, more than $100 million US in investment in the manufacturing equipment. Whatever the machine is to be able to produce the result satisfactorily, we will invest in that. We'll have a look at some images in a moment of some machines, but it's not just a computer, the software and all the rest of it. It is the manufacturing side of it as well. It's continuous software development. There were 4 upgrades to the software last year. There's an optional upgrade already this year, which will be forced out in about 2 weeks. CAD CAM Academy for dental designers. We're a globally recognised training organisation. At our scientific symposiums, at various exhibitions, we run updating courses on the software. We train all users on the software. We have 2-day training courses. We have monthly WebExes or webinars where people ring in, log online with their computer, and they focus on designing one specific, an overdenture bar or one specific product. So it's ongoing training and education as it's changing. We have 4 production centres around the world, in New Jersey in the States, Stockholm in Sweden, Tokyo in Japan is our regional one, that's where most of our production is done, and Quebec in Canada. Quebec in Canada specialises in a lot of the bars, even though more bars are being manufactured in Japan now, in Tokyo. Okay, 2 decades of experience in CAD CAM, 10 million NobelProcera restorations are placed. These slides are a couple of years old, so it's a lot more than that now. This area, these are older milling machines now. I think there were some still there when I was over in Japan, but these are the older style ones. The newer ones now are bigger, higher speed. But this is one section for one material type in one factory. So this may be alumina, for example. Then we have another section in the building which is for zirconia, another section for titanium, another section for cobalt chrome, and another section for the overdenture bars. They all have the machine that's best designed for that purpose, that manufacturing purpose, and we have that same setup replicated amongst all the manufacturing plants that we use. Are you okay? Did you add anything to that?
No.
No. Jump in.
Yeah.
In terms of raw materials, yes, of course, we use the finest raw materials. All of the bars and things like that, and I'll have some of these things down here so people can come down and have a look at later on if they want to. We have some samples, but they're all milled out of solid blocks of titanium or